William, the time is yours.
Hi, thanks, James. Welcome everybody to another session. SIA have been running this knowledge series, in fact, quite a number of them already, especially on computational design. So today we're going to have an exciting afternoon. Before we introduce the main speaker, I'd like to just let the sponsors for the event, basically Graphisoft Asia, to kick off the introduction. I have here with me Edmund Lau is the MD for Graphisoft Asia. Let him start the ball then. Edmund, to you.
Thank you, William. And hello to everyone. A warm welcome to all of you. And thank you for taking the time to join us in this SIA and Graphisoft co-organized event. We really appreciate the opportunity to become a sponsor. Just to give you some background of Graphisoft, we are founded in 1982 and is part of the Namanchak Group since 2007. Being a pioneer in BIM, Graphisoft dedicated our work to create the best-in-class BIM solution to the AEC industry. Architecture has a very deep root in our culture. We first developed our Archicad software predominantly for the architectural industry. We are well known as a product designed by architects for architects. Today, we have expanded our solution to the multidisciplinary segment. We believe that the journey of BIM starts with enabling our users to be competent in using our software. Together with SIA, our shared objective is to support and nurture the architecture industry, fostering knowledge and learning, as well as the sharing of efficient and innovative way of delivering high-quality projects. We are also supporting our local industry transformation roadmap by fully alignment with CA initiatives such as the Connect X and the IFCSG. So do contact us directly if you want to find out more. Today, we have the privilege to have Henrico from Enzyme to share with us their experience and insights on sustainability design using BIM. We hope you enjoy and benefit from this session. Let us continue building together that is both innovative and sustainable. Thank you. Back to you, William.
Right, thank you, Edmund. Graphisoft has been a so-called very friendly vendor with SIA. We've been running a lot of programs together. Like I mentioned earlier, computational design is not new. Right? We've run a few series on that already. But however, I think in this session, we're going to raise the bar a bit by introducing sustainability. So the next speaker will be touching on not only just computational design, but how we can use that to overcome the issue of sustainability, which is on everybody's mind now. All right, Henrico. Okay, let's talk about the speaker. Henrico is a computational designer, right, at Enzyme APD. He's been working very deeply in computational BIM in the past 2 years. His experience mainly in the realm of parametric design applications, both in residential and hospitality projects. He's a lead green associate that explains why sustainability is on his cup of tea, with a special interest in data-driven sustainability design. That's going to be a very big mouthful. So I think without further ado, let's welcome Henrico. Henrico, to you.
Hi everyone. Thank you so much, Architect William Lau. So today I'm going to start sharing my screen. Then we can start from there. All right. Hopefully everyone can see my screen right now. Yes. So today we are going to talk about sustainability in practice. So basically we are Enzyme. My name is Henrico Teguh. I'm actually based in Singapore. I'm born in Bandung and currently based in Singapore. I'm a computational designer in Enzyme APD. And yes, I'm a lead green associate as well. So I'm just going to give you a bit of insight of what I have done in the past. Give me 1 second. Yeah. So sustainable design and computational design is something that is very close to my heart in my MArch thesis, which is the one that you can see on the left. I graduated from SUTD actually. So like this project that I had, it was about circular economy, about how we can actually use digital materiality to make our building to be much more sustainable in the sense that it can be long lasting and help like buildings that has been around for a longer time. So in the past, I also worked with SOM, Tan Design, and Boyer Mellon, and also WOHA. So I hope that my experiences that I have actually gathered inside this realm of sustainable design and computational design can actually maybe give you some inspiration. Yeah, as well as definitely I'm going to explain to you what we have done in Enzyme APD. So via Enzyme APD, we focus on architecture design, urban design, and digital consulting. We deliver deeply digital projects, utilizing data and technologies and tools to inform and deliver our projects. In our design firm, right, we are a group of experienced designers with international experience and detail-oriented process. We work in different skills: master planning, architecture, interior design, crafting our concepts and design in our clients' need, bringing together our design expertise with our client values and expectation, creating sustainable design, environmentally, economically, and socially as well. So in our core, we are digital consultants. We are digital savvy and passionate about things, how things are done. We have research group within the company that explores new workflows and techniques, from BIM to computational tools that we always use every day. And we also offer this as our service to our clients. We are BIM and technology advocates. We are in Hong Kong, we are official Archicad training center, and we know BIM experts. Since 2015, we are an official Archicad training center in Hong Kong. And within our team, we have certified trainers and registered BIM consultants. We also travel the world, giving lectures and conferences, showing our experiences and inspiring other professionals to work better in terms of BIM. And we always attempt to be on top of the new tech that improves our quality of work. So this is us. That's Jorge and Eugenio. Eugenio actually is here as well with us. Later on, he's available for us to do the Q&A. So yeah, we believe that we want to bring together design, efficiency, and innovation together. We come from different international backgrounds, giving a global perspective, operating through the idea of genus loci, connecting with experts and consultants from all over the world. We'll be able to provide the best knowledge to our clients. So this idea is very cool because basically we are located like from all over the world, and we actually be placed locally to understand the local condition and localities, and we basically be able to actually provide you services according to where your locality are. So this is our past collaborators, Takenaka, Lotte, and a few more. Then we'll actually show you some of our projects that is part of collaboration with all these people. Not all of them. Yeah. So Power with Archicad BIM, right? We are looking into the finest control in the widest scales. We believe in understanding the projects as a whole, from the superstructure to the smallest little tiny details. When we talk about BIM, right, it's not about just a submission model. It is where information merges and bear fruit. Even the larger kinds of projects, we ought to retain the smallest control of the details. We work in various skills: master planning, architecture, interior design, crafting our concepts and design to our clients' needs, bringing together our design experience with our clients' values, from outside, inside, to the smallest little details. The philosophy of parametric design allows us to control and be able to expect what is designed, and we have this freedom powered by data and BIM. Yeah. So if you have actually looked into computational design, right, definitely you have already experienced this ability to actually know exactly what you want and be able to expect the result that you want, which is super cool. In Enzyme, we use Archicad for design to enable our design, and also basically create smarter workflows on our design. Yeah, supporting the integrated design delivery, the IDD process. If I'm sure everyone is actually quite familiar about this. We look into projects from start to the end. And to this talk, we are going to talk about just focusing on how we apply sustainable design in our practice. With parametric design methodology, right, we are able to create quick and iteration that was proven to be helpful for sustainable delivery for our projects. This is a very quick video. It's like a 1.5 hours webinar that we did. And this video is just showing how powerful it is. Basically, we just create a form, then we are able to actually divide into the form itself and straight away bring it into Archicad. And with this, you can see that the process is extremely quick, where all the building design, the building elements is already baked in as how we want it to be. So it's pretty cool to be able to see how computational design and BIM actually can merge together and help you to actually inform our design. So applying the idea of BIM and parametric thinking, we start from the site exploration. Like this is a site is like point data. So it's just a diagram how we can actually modify our sites, something like that. It's a very quick tool. Then we explore the idea of like terraforming, because at the end of the day, when we are actually designing, we should be able to understand our site. We also implement our sustainable design tools from Ladybug or Eco Designer. Yeah, those things. Then we also definitely feedback it back to our Grasshopper and data analysis tools to actually give us a better informed design. And this is an example that we are using for WellSA genetic algorithm that enables you to actually find what is the right design for this kind of plots. And definitely because of BIM, we are able to actually manage our data quite well. And in Grasshopper, we also use this idea of elephant that help us to basically manage our data of our elements of how the buildings actually be. Yeah. So data-driven design, I think it makes sense. And this also helps us in a formal exploration. So our exploration is not very messy. It's not about, okay, this is a line that is perfect. No, it's not. It's about data. It's about how we can actually use the environment and the site to inform our best data design. Yeah. So finally, this is just the end about how we work. We actually finally created this hybrid workflow where we actually use Grasshopper and Rhino as well as the Archicad to actually create data design that is data driven and also can be communicated very clearly and very well. Yeah, during the last 10 years of BIM and other digital tools, we have slowly made our way and our changes our practice, how we can actually work our design, and it tremendously improve our flexibility of designing. BIM have changed our workflow for the better accuracy, better understanding, better information, better consistency, better coherency. I believe if you have been using it, you know this quite well. Yeah, managing information is much easier now. Instead of referring to sheets after sheets of data, cross-referencing, making sure all are correct, we now can create information baked within the geometries itself. Information of material types to the material information like the ambient carbon or global warming potential or anything else, or all are actually readily available for us to use within the Archicad BIM itself. So that's how we work. This is our journey. We start from Archicad. That's our genesis. And we start to actually explore further, understanding the data. We integrate Grasshopper into our workflow. And finally, right now, we are actually exploring how to use even more. You are using APIs of other softwares, using Python or Airtable to actually communicate our design and relate our data to whoever collaborators that we are working with. That's basically about Enzyme and about how we work. We are going to tell you about Singapore and the world and about the sustainable design as a background information. So now first we are going to talk about the world. So there are things that can be applied globally when you're talking about sustainable design. I mean, the world is just one way. I mean, the world, wherever we are, the localities is different, but then there are things that are actually common. Yeah. So let's look into the world first, and we can understand what is actually the reason of, or if you do not have any reason yet, like why sustainable design is important. So looking into our future, if we continue doing our architecture like what we are doing now, right? We are creating long-lasting buildings, but then we continually demolishing them and rebuilding it again. It is not it doesn't sound like the most sustainable way to build our world. In the bigger picture of world impact, our industry construction contributes the largest in extraction of materials of the earth. You see here, it's 69%. The question is, how do we make them sustainable? In the idea of circular economy, we have this idea of reusability, of how we can actually use the material again and all this, but it's something that is we need to continue to think about. So let's talk about something a bit closer to our realm of control as architects and designers of buildings. The process of creation of building itself and the operations of them. Around half of all non-renewable resources of mankind consumes are used in construction, making it one of the least sustainable industry in the world. The largest contribution also meant that there is an incredible opportunities for embedded carbon reduction in these high impact materials through policy, design, material selection, and specification. So we have some example from Singapore. In Singapore, some things about Singapore, I mean, everyone is very familiar about this. It's heat, humidity, rainfall, the UV, and also the, at times, very chilly wind. I think right now, at least from my window, it's quite nice. It's very cloudy. It's not as hot as yesterday. Yeah, but in bioclimate design, are effective, and we need to focus on preventing the building envelope from overheating in the first place. That's what we should try to do. Sorry. In Singapore, right, we saw the scattered placement of buildings, their form and orientation. The use of side green will also create the optimal climate at the urban level. On a building level, solar shading device, stack ventilation in combination with evaporative cooling, roof gardens, or double ventilative roof construction are worth mentioning for us to actually look into. Most of you might be more familiar about this project than many of us, but we really like the idea of how we can enhance building with technology that help us to achieve sustainable goals of ours, combining the regional architecture and the new technologies, creating synergies and good design for occupants and the environment. We believe as designers of the built environment, we should be inspired by each other and how we can make our world better. So now I'm going to talk a bit about the BIM world, okay? So the pursuit of sustainability has become one of the principal design objectives in our construction industry. And this response to this concern, the integration of building information modeling, BIM, and sustainable practices could have actually helped us a lot. Built environment cannot escape its responsibility for contributing towards environmental deterioration and destruction of arable land. Luckily for us, we are living in the world where BIM could assist us. With the application of BIM and understanding its inherent power, it will greatly impact our role in optimizing the performance of a building. BIM is rooted on its innovation, cost efficiency through more information and collaboration, construction and commissioning of buildings with lower environmental impacts. All right, borrowing sustainable design philosophy from the US GSA, when we think about sustainable design, we should attempt to make decisions that will reduce negative impacts on the environment and the health of equipment. There are many ways for us that we can actually try to tackle it. Today, we are not going to talk about it too much. We are going to talk about how we actually do it. So, yes, making better decisions at each stage seems to be the most critical part of achieving a more sustainable design. So everything that we think about when we are talking about sustainable design, we should actually try to think how we can actually incorporate this idea about sustainability, how we can actually change this small little thing that maybe actually give a lot of impact. How BIM can help. Built environment cannot, so information access, as we said, enable collaboration and simulation and analysis. It's things that BIM can help, and I'm going to show you how. So that said, we have already talked about the context. We talk about how BIM actually might be able to help us. I'm going to show you how we actually using it in our projects. Followed by BIM, we want to show you this our projects. Okay. First, we are going to start from the site. This project is called Linear Loop City. It's one of our several collaboration with Takenaka and its computational design team. This project won the first prize in the Ilong Smart City competition in 2017, quite a while ago. And it is a great study on how the companies can actually collaborate, giving the best of each other creating a synergy of design. So we are operating in Archicad environment where we can actually collaborate across companies, across groups as well. The brief was to create a new smart city near Yulong County in the Sichuan province, and this is to provide 30,000 people home, merging the rural pre-existing life and the new modern concept of a city. So the idea beginning the start of the project, we want to create this loop that connect different city clusters in the most efficient way, acknowledging and respecting the surrounding landscape, because this is quite a nice landscape, a nice topography, a nice scenery. So we are trying to make sure that we didn't actually intervene too much. So we want to keep the road at the same level to optimize the movement of the proposed transport system using the smart electric vehicles. First, we find the best areas within the terrain with the least inclination. This is in order to minimize terraforming, thus optimizing the investment and construction processes. For that, we created a routine in Grasshopper to analyze the terrain, acknowledging the slopes, and while also analyzing the potential of flooding area. So this is, as you can see in this video, right? This is actually a running video of how we actually analyze the levels from the bottom to the top. And we can see there are areas that is better than others. Blue means it is less slopey, much more gentle, and red, it is very steep. So this is just a what simplified way to see our diagram just now. So the Grasshopper script provides us the colored analysis mesh that you can see here. And this part, you can see the gray area is where the area have slope that is less than 9%. This gives us a preferable area to actually take this as the main level of this whole development. After that, we also select the range of proximity of the selected road path, and we are able to actually see what is the buildable area when we are actually dividing according to the slope steps, as you can see in the diagram. So this is what it looks like in the Archicad 20. Now we are in Archicad 26. So we can see that information is being processed quite well in Archicad, when we can actually see all the meshes with the terrains, and we'll be able to look at how our intervention actually is. One of the greatest challenges of this project is physical size. It's 2 km by 2 km. It's full of terrain complexity. For this project, one of the most important aspects of this project was to study of the terrain, as what we explained just now, to create this loop road. And Archicad can handle the meshes, as you can see, but the problem is that when we are looking into a bigger picture, larger scale, it's quite hard to manipulate. So that's why we are actually opting to look for Rhino Grasshopper to help us. So this is actually a Rhino model. And the cool thing about Archicad and Rhino, we can actually use this idea of hot link, and we can terraform the road formation in Rhino and straight away plug it back to Archicad. And this can be seen from these diagrams that is from Archicad. You can see that it can clearly tells you what exactly is happening around this area. So if it is successful, if it is not successful, you can see it straight away. It's very quick with very little post-processing. So these tools really helps us to actually give us a much more informed decision of how we can actually design. These are just some snips of the final boards. So like the idea of this ring linear city also is very important in the sense that because of the site that is very beautiful, we want to preserve as much as possible. So this ring linear city is able to help us to actually maneuver through this whole terrain instead of like creating a flat land and make it and call it a city. Yeah, it's pretty cool. So this is how it looks like. Yes. So with that, right, so we talk about slope analysis to basically locate where is this axis of our building. Basically, we can start sustainable design from the site level. Now we are talking about the building level. So when we are talking about the building level, it's a bit different. We are looking into deeper how the building actually works in the certain site condition. So this is a KL project, it's a KL Heart competition. It's a collaboration with Plus 8. In Kuala Lumpur, Malaysia. The tools that we use are Archicad, Rhino, and Grasshopper. This project site sits in a very prime location, just beside the Menara KL, in the middle of the Golden Triangle. It is the last mature rainforest within the city itself. It has a complex topography as it sits on a slope, as that we are going to show you later. One important feature of this brief was how our intervention sits on the whole cityscape of scale. So skyline is a very important. So we need to be able to make sure our design have some relationship with the Menara KL and also the Petronas Tower. It is a massive development for 500 square meters, 500,000 square meters with a plot ratio of 14. We would like to, for this project, we would like to emphasize the importance of preserving the pre-existing condition as much as we could, because this is a mature rainforest, as I mentioned before. For this project, our main idea is to lift the ground floor, instead of creating blocks, which is common in the surrounding areas. We want to get the landscape to flow within the ground floor itself. So as you can see, this is the ground floor plane. We can see how the buildings actually maneuver through the landscape itself. So we can see, I want to explain to you a bit more about the slope itself, the site condition. So this is the site terrain. If you can see, it is actually quite slopey. If you can see here, this is the steepness of steepness analysis. Then we basically look for areas where the areas is actually the most flat. With that, right, we are able to actually locate our foot of our buildings. And with this idea, we are able to actually make sure as much as possible to reduce the intervention that we did in the ecosystem that we have here. Yeah, so we introduced the main axis throughout the project, and this is the whole script. Actually, at the end, right, if you see here, it is actually an Archicad connection. So all our design that we did in Grasshopper and driven by the technology, driven by the data, we can straight away pull it in to Archicad for visualization and understanding of the building much better. So this is just a video of the whole process. This is a steepness analysis, and we are locating our Grasshopper, we are able to actually find this location and basically create operations that help us to design much quicker instead of like drawing one by one. You know? So for our project, even if, for example, the site condition impact actually is not what we show, maybe there is a better information available, we can actually just move our points and make sure that and make the whole script to run again and basically create a iteration of design. Yeah, it's very quick and it's very good for us because we are data driven. So this is some diagrams that we use to explain our idea better. So these are the site condition where the greens are within the project itself. This is the automated parking because we want to make sure that we have the least road as much as possible. And this is the building mix of this project. And this is how it might look like when it is connected from one tower to another. So this is just some visualization of how the building is and some sketches. And this is a render of how it sits in the KL. Yeah, so that said, right, we talk about site where we are actually looking into the bigger picture. Then we talk about the building level, how we can actually place these buildings to our most benefit, and also basically help us to create much better design to reacting to the site itself. So now we are going to show you an example how we can actually integrate it even deeper to the element level itself. So we are going to show you an example that we did. It's a cool project. It's a very collaborative project. So this project is called the Net Zero Building. It's a competition. It's a research project. It's a project that we did with Andy Thompson and many other experts that is right here. It's located in Hong Kong, and the tools that we use, Archicad, Rhino, and Grasshopper as well. So, yes, so the site is around 6,000 square meters and 4,000 square meters of buildable area, 94,000 square meters permitted GFA, with 2,000 green area requirement for this project, and 1,000 of them have to be on the street level. So for the first step of this project, we need to understand the project site condition compared to our other projects that we show you just now, right? This project is actually a small little plot that is surrounded by buildings. So we need to understand the building and how the whole system actually works. So the surrounding buildings is, as you can see here, is around 20 to 40 stories height, pretty tall. And the lower side is actually looking into the sea. So, and the prevailing wind is from July, there is this monsoon wind, and it is very, very strong. And it is actually going through all these tall buildings behind our site, and which creates a very, quite an intense wind tunneling effect that we need to consider. Then from the northeast and the east area, there is this summer and winter wind, and the sun is predominantly coming from the south side. Yeah, because this is a Hong Kong project. It's not in Ecuador like us, where we are exposed from the roof. Yeah, so this site has an unblocked sea view, which means that it has direct sea wind exposure. And being at the edge of the city, the project is at the beginning of the urban island heat effect. Yeah, with all these parameters understood, we start by looking into a concept where we can use this heat and wind to our use instead of like, no, but then we want to use it so that our building is better. So on the right diagram, as you can see, is how the conceptually the building should work, where we utilize the heat, we utilize the wind to actually help to design our space. Yeah, the urban heat island is tackled also the idea of double facade cooling system with the planter fixed in it. This is the site. So as we have already explained, the south and the north are quite different in the sense that how we need to tackle it. So the south is where the sun is. So we locate photovoltaics cells, PV cells, to basically try to gain the solar energy there, while also providing shading to the space. In the north, where there is the prevailing wind, we need to use the double facade system that actually help us to mitigate how the wind actually blows, basically creating a breathable ventilation that we can use. So overall, for this whole building, we also thought of to use ceramic facade system that enables us to do a overall cooling, and something that we will explain later. So for this project, we are quite intense in the sense that we are looking into the data of each and every single points that we are trying to make. So these are the approaches that we have. We have 9 approaches that I'm going to just tackle it one by one for you. Yeah. So the first one is this idea of the right material in the right places. So as we all know, right, when we are creating buildings, what is important is the construction system itself. The core takes a lot of the embodied carbon in our building. So this important thing, as if you remember just now when we talk about how the construction industry takes a big chunk of the extraction of material from the earth, right now we are contributing 40% of the carbon consumption yearly, So this is very important for us to try as much as possible to offer low embodied carbon option. So this idea, like when we are talking about material choice, there are things like bamboo, the highly engineered bamboos that can be used in our structure system, or green concrete, like the carbon cure for our core, that basically lowers the overall embodied carbon use for this project. So there are 5 things that we thought that it is very important. So the first one is the minimization of the load-bearing elements. So in the sense that we have to try to create the grid as effective as possible instead of creating cantilevers or transfer elements. We need to be able to basically create an effective way to structure our building. The next one is the material choice, like what we mentioned just now, the Lambu, the carbon cure, concrete, or many other choices that we are going to also show you how we can actually utilize in our practice as well. Functional durability is a very important thing, in the sense that it's true there are things that is like maybe better in the sense of the low embodied carbon, but then if it doesn't last long, that will be a problem. We need to be able to find where is this nice middle ground where we can actually find a good low embodied carbon while also maintaining the durability of the project, of the material that we choose. Increased use of recycled materials is very important, because as we can say, just we have already seen the statistics. Most of the waste of construction is not actually being reused, and we are actually able to think about how we can actually use these recycled materials, or even the idea of digital materiality, using systems, partition systems that we can actually reuse, recoup, reassemble those things. Very important, and it's possible in our design. Lastly is the reduced maintenance. So this idea of reduced maintenance means that we need to find something that is right for that condition. So we are not using, like, for example, steel, corrosive steel in the sea, you know, that'll be rusty, then you have to keep replacing it, or the paint that doesn't long last, you know. So this kind of thing we need to think about, and we need to make sure that we are trying to reduce it, the carbon impact as much as possible. Yes, this is just an image of the interior of the project. So next one, when we are looking into the building level, we are talking about the massing as well, and optimizing it for the site condition. To achieve net zero, right, we need to try to minimize the energy to use during the operation of the building itself. So just now in the beginning, we talked about the materiality and how we can actually create the structure of the building. We need to look, not only that, we also need to look into the massing that we are actually using. So if you can see here right now, we have this building that we designed. We have two towers, one shorter one taller one, and that is for a reason. So just going to talk about it a bit more. On the next slide, we are going to talk about the shading a bit more on the next slide. So we are also talking about, like just now when we are talking about the double facade, we have to use the prevailing wind instead of like preventing the wind to come in at all, because at the end of the day, this wind are actually free energy for us to use. If we can actually optimize it and utilize it, it will be awesome. Then utilization of the microclimatic effects, in the sense that if we are actually introducing like gardens or parks or water bodies on the ground level, we shouldn't like let it stop there, but then we need to we can actually use it to actually improve the site condition of the ground floor as well. So as you can see, this project, we elevate the project from the ground plane to actually allow the public realm to be naturally ventilated, and it have connection, this connection to the new urban park that creates this hydroponic tower, allowing for ambient cooling from the water vapor of the ground floor. And it enables for the community-centric activities like hydroponic farming to even happen. So this is the thing that I was mentioning just now, how the tower massing can actually help. So this in this project, where we have the taller one and the shorter one, the taller one is actually located on the taller area of the buildings, where the surrounding buildings like 30 to 40 stories high. Then the one that is shorter actually is looking into the sea, where the buildings are surrounding buildings are 20 stories high or something like that. So we are, by utilizing this, right, you are able to actually reduce a lot of heat gain, and we are able to, I mean, like when we are talking about facade, we can talk about double, triple glazing. It helps. But then at the end of the day, when you're talking about the urban heat island effect, all this reflected heat will still be there, you know. It's not going to be absorbed. It's not going to be help. You're going to actually worsen the surrounding condition. So this is something that is important for us to consider. So we talk about the facade design quite a lot. So I'm going to go a bit deeper here. So this is what we are opting for. The idea is to create this double facade system, because when we are using double facade system that doesn't have too much of reflective elements, we are able to prevent this reflection of heat of from the sun to actually create this more intense urban island effect. So we need to, by using this double facade system, we are able to actually lower it down and make sure that even not only the building that is being cooled down, but then the surrounding of the building is also much better. Yeah. So there are three purposes that we thought that facade is that facade can actually contribute. So the first one is the reduced energy consumption. As we said, if we can create this facade system that already filters out the heat instead of like reflecting it for the urban heat island effect, you can actually help the air quality intake that we are going to use later on, that I'm going to show you. Then next one is the, like what we say, to mitigate the urban heat island effect. And the last one is actually to improve outdoor air quality intake. So this is very interesting. The last one sounds a bit far-fetched in the sense that how can the facade system improve the outdoor air quality intake that helps the indoor? I don't know, but then that is possible. We are going to show you how. So using this ceramic water pipes that we opt to use, there is a chance of 12 like research shows that there is a possibility of reduction of 12 degrees Celsius to basically reduce the heat of the air from outside, and compared to the one that if we suck it in and put it inside our building. So with that reduction, right, means that there are a lot of impact. The impact is, like, for example, if your air intake is already cooled down, when you want to cool it down further for your air conditioning, it's just a bit more. It's just a bit, way lesser energy is required to actually reduce 1 degree compared to reduce like 15 degrees, you know. So this, by choosing a system that actually enables us to already pre-treat the air before we actually use it, is going to help quite a lot. Yeah. So using these systems, we hope that we can actually reduce the urban island heat effect as well. That is actually very important. Just a few of image. Then the next one is passive energy to reduce overall energy demand. So how does this work, and how we can actually use it? So knowing the locality, opportunities and constraints is very important. So as this project is located in Hong Kong, we have this sun and heat problem. Not problem, I mean, it's opportunity and problem. Constraints: rainfall, wind, and hydrology. So the sun and heat, I think it's quite simple. It's very straightforward. We are using photovoltaics to actually capture the energy to actually use for our building, reducing our energy demand for the electricity. Then the double skin facade also helps us to reduce the heat overall for the whole building to be cooled down. The next one is the rainfall, where we are using the rain harvesting and the HVAC system that utilizes this rain harvested water that basically helps us to cool down the whole building. How it's being used is basically, you know, just now I mentioned about the ceramics pipes. We basically run the water through these pipes, and it helps to cool down the whole building skin. Yeah. So the next one is the wind, how we can actually use the ground floor, the massing of the building itself to actually take opportunities that we have. Like, for example, by lifting up the massing, we are able to actually use the wind that is already existing on the surrounding realm. Then the double skin facade is as what we have explained just now. We can actually regulate how the strong wind at the higher levels to actually being regulated, and we can actually use it. So the last one that is very important, very interesting, and very specific to this locality is actually this hydrology. So in this idea, right, because this project sits on the coast, and it's on the coast, means that there are a lot of water from the ocean, right? We are looking into the use of sea water geothermal cooling system, in the sense that we can actually use the water itself that is colder than the room temperature or the temperature outside, and basically help us to chill the whole space. Yeah. So what is cool about this also is actually because the developer that is working for this project actually owns the whole space, the whole area of this plot and the surrounding. So there is this talk even when we want to see if it is possible for us to actually create a centralized like water cooling system that basically can be used for the whole facility. So this idea of centralization is quite interesting as well for us to explore. Yeah. So next one is this idea of HVAC system for energy conservation. So this is quite interesting. Okay. So like what we have discussed previously, right, where the air intake has been lowered in the temperature, preheated by the ceramic pipes, we are looking into the HVAC system itself. Okay. In this project, we opt for the decentralized under-roof cooling system, taking the cooled air intake and actively cool the air further on each floor. So just now when I say that the air is like lowered by 12 degrees Celsius, means that if it's already good enough, then you don't need to cool it further, you know. So, but if it is still required, you can cool it further. So with this idea of floor by floor control system, you're able to actually create much more control in the energy usage of the whole building. So yeah, with this system, you also allow for the separation between the corridor and the tenant areas, which can be individually controlled, which makes the whole system even much more effective for the project itself. Yeah, each system also equipped with the filters, sensors to ensure the quality of air within the spaces. Yes. So next, this slide, it shows about the energy conservation. So this energy conservation, it's very interesting concept in the sense that, you know, when we are talking about cooled spaces, oh, because we are in our world, very often we are using this idea of glass facade, right? Even though it's enclosed space, this heat exchanges still happens. So we thought that the idea, if we can actually prevent this from happening, is not happening. I mean, to reduce this from happening, it'll be even better. It'll be good. It'll be beneficial for the project. So first, this diagram, the one that you see on the right, we can see that it is strategic. We thought that strategically locating a cooling system is very important. So just to ensure that there is just enough for us to provide the whole space, and our engineers also provided some figures of how many heat exchangers is required to actually make this space operates as what we expect it to operate. This new air unit is a high performance heat exchangers. They cools pre-treated air and dehumidifying it as well. And this project, using this heat exchanger, there's always still byproduct. And this byproduct is like water, hot water or something like that. We can actually use it for our F&B, cleaning or bathroom, or basically gyms, showers for the whole system. Then the next thing is the retaining cool temperature. It is important, and because we are aware that we are actually using a lot of energy to cool a space, right? We have to try to retain it as much as possible. And luckily for us, also the facade system that we opt in is will be able to create these microclimatic effects that help regulate the retainment of the cool air from outside through this evaporative cooling system. And lastly, we also need to look into this usage of natural renewable resources like the seawater geothermal cooling to supply our system. Yeah. Next one is this idea of sustainability. The is community focused. So, you know, like when you're talking about sustainability, very often we are only talking about this idea of embodied carbon, about how much energy we consume. But then sustainability is not only about that. It's also about the people that actually uses the space and how we can actually improve the people, the life of these people around us. So with these resources, the byproducts that we use, right, for the whole building that is being as it is being operated, right, we can use this rainwater or the processes. We can straight away supply it to this hydroponic or aquaponic farms that can be interesting for the community to use, closing the loop of the whole system, and also at the end producing vegetables for the community, which is cool. Yeah, so the idea of sustainability is not only about the building itself, it's also about how we can actually help the community around us. Just an image of how the ground floor was envisioned to be. And finally, this is a very important concept as well, and actually is very easily usable for all of you in many of our projects that we might be doing. So in this project, in partnership with Clestra as well, right, the smart partition system manufacturer, the partitions are removable. The partitions are fast, but it is the thing is that when we are creating like office spaces, right, when we create partitions, right, we just we put partition here, partition there. It's very fast, but then you are not able to reuse it if you didn't think of reusing it in the beginning. So a lot of this partition actually being knocked, then just become like waste for the landfill, basically one of the largest pollutants of our world from the construction industry. This Clestra system enables this partition to be reconfigured, reused, and maybe within the building itself or even outside the building, because it's a modular system. This system is very quick to assemble and disassemble, and you can, like, for example, you can call them in the morning, then they will do it, then it will install the partition, then the next day you can already use it. It's a very quick and modular system, and even if you don't want the partition to be there, you can remove them as quickly as it was assembled. Just a small story, right? Because this project we presented to the client, to the developer, right? And it's quite cool because they actually took this idea to their project, to real life, where they use this Clestra system for one of their temporary offices. And using this system, right, you are able to, when this office space is actually being leased out, you can actually just remove the partition system and everything will be fine. You can reuse this partition system again for other projects that the developers has. So maybe it's something that is interesting for you to look into. So last one, this is very important, the data and calculations. So when we look into buildings, right, we have been talking about concepts of how we can actually reduce it from the facade side, blah, 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 blah. But then we have not talked about how we can actually look into use of BIM to actually help us. So when we are using BIM, we are able to actually find the data and input the data that we actually acquire from the world and the surrounding, and we are able to actually assess it of how it's being used in our project. So looking at this, we can extract the key variables of the buildings from the locality, the energy cost, the grid load of how the grid is actually generating energy, basically just performance data. And from then we can actually look to how to optimize this whole system, because at the end of the day, when we optimize things, right, we need to be able to be able to know what is the benchmark is, right? So this is just a slide to show you like what are the things that you can actually gather from the project, from the building project itself, and from the surrounding. So here, this is a benchmark targets to be optimized. So where we can actually, basically we are understanding the whole similar topology of the buildings, then we find the areas we can improve. So thanks tools like Eco Designers in Archicad or Ladybug, we are able to understand the use of energy into even the granular sets of the data, like even the day, the date, the hour. These kind of things are able for you to use, and it's going to be very useful for your projects if you are looking into the sustainable design. So we can help us with this, we can help ourselves to find construction solutions, and even finding different solution and test it out, finding what is the best way to actually move forward to create our building. Yeah, sometimes from this collaboration project, we found that at the end of the day, right, sometimes, right, it can be a facade design solution, it can be MEP system solution, or even maybe it's about the usage, the people that is using the space itself. Yeah, so if you see the small little text there, yeah, maybe one of them is actually how we can actually educate people how to use the system. Yes, so these are just some images of the whole project. Yes, so that's basically the three approaches that we use, from the site, the building, and finally the element. So now we are just going to have some concluding statements, in the sense that how we can actually wrap this up and understand how we can actually utilize the system hand in hand. Okay, so our built environment and its interactions with the natural environment are very complex. have a massive impact on the world around us. Hence, sustainability is a complex concept which encompasses not just energy, but all the resources needed to support human activity. A large part of the building sustainability is concerned with addressing the global warming, driving the climate change, using energy conservation, and techniques such as life cycle assessment to maintain the balance between capital costs and long-term asset value. It is also about enhancing biodiversity, creating spaces that are healthy, economically viable, sensitive to social needs. And rather than constantly battling against natural environment, we start to respect the natural systems and embrace it, learning from the ecological process, creating a better balance between human need and wider environment. Our good friend Andy said, any architect could design zero carbon buildings with a bit of help from a good set of tools. So we want to show you how we actually use our tools. So so this is the standard tools and versus custom workflows. So like, as we have kind of like touched upon some of the ideas, we have this eco designer, ladybug and all that, but these are standard tools, but then how we can actually help ourselves to make it even better. So in Enzyme, what we do, we actually develop Graphisoft Archicad GDL objects, that is custom objects that help us to understand our building system. Then custom C++ add-ons to basically help us to analyze how our building system actually works with each other. And the last one is Tapware, which is a add-on for Grasshopper and Archicad to basically help us to manage the data and understand how the building actually performs, or even like visualize systems that we are interested in. So we have this custom Archicad GDL libraries that I'm going to show you very excitedly. So we create this nifty tool that enables us to access information of each building material, even when it is used like as composite. If you know, in Archicad, we use walls can be composite, where it actually contains multiple different elements. So using this tool that we have developed, right, we are able to actually look deeper, not only one level, it's not only about the facade, but not only about the finish system, but then also the core system, the insulation system, everything that you have here, you can access. Because at the end of the day, BIM, right, all this information is readily available for you. It's just for us, the question is how we can actually utilize it. So this is just a small little video of how this labeling tool actually helps us to look into the system. So you can change it. You can find like what are the things that you want to use to analyze the brick, the render, or the insulation. All these informations are already readily available in BIM. You just need to be able to access it, and this tool helps us to actually understand this system very, very well. So things like this, you are able to even like add your own information if your locality have different kind of information. So using this information, you can actually replace the database according to what you need. And using this database, you can actually help to basically understand your building much better. So Andy Thompson, which is our very good collaborator, so he used one of our other add-ons. This is called the energy labeling tool. It's super interesting because if you can see these composites that you see here, you can actually label it and see how the global warming potential is, how the emitted carbon is actually being described for that particular composite. Or maybe the last one is actually the thermal conductivity of the whole system itself, because I mean, like, maybe in Singapore it's not really important, but then in the Western Hemisphere, where cool extreme degrees of Celsius, extreme temperatures are actually affecting them daily, day-to-day basis. So this is super cool, and we hope that these kind of tools actually can help us to inform our design much better and communicate our decisions much better. And with the highly customizable interface, it's also basically enable you to make sure that this is working for your projects. And yeah, it's very cool, and it's very important for us to we thought that it's very important for us to be able to understand this correctly and not just through text or schedules or Excels. So last thing that we want to show you is this Eco Designer. Very cool. This Eco Designer is actually is a built-in tool in Archicad that enables us to do building energy modeling within the project itself. So as you can see, you can select different things. Then for this example, just this small little window here, we can see how much solar gain, the solar heat gain is being actually taken by this window. And even we can even look into the small little details on when it is happening or the reflectance of the project itself. So with this kind of information, we can look into the solutions, how we can actually mitigate this kind of problems or opportunities. So lifecycle and analysis is a scheduling tool in Archicad as well to basically help us to understand the life cycle of each of every single material that we have. And this is very cool in the sense that when we actually update our materials, for example, you want to choose a composite A to composite B, all this calculation is automatically pre-calculated, and it helps you to inform, basically informing your design how we can actually improve it, or maybe no need to be improved, no need to be improved anymore because it's already good. So these kind of things are is already readily available for us to use, and we hope that we can actually use this much better and much more in the future. So this is the final slide for the whole thing. So the parametric design and BIM, right? We use technology to enable our design to achieve high level productivity, accuracy, and reliability. And we hope that you can also be inspired from us in the sense that we can use these data and the tools that is already readily available, or even use our own customized tool for you. And you can check our website, and maybe we can make the world even better. These are some other add-ons that we have, the tab here, the GDL objects, and that's it. Thank you so much for listening. My name is Henrico, and our vendor is Jorge and Eugenio. I believe Eugenio is here with us, and we are ready for Q&A as well. So thank you.
Wow. Thank you, Henrico. That was really huge content, right? I hope the participants here have taken